Hello all, welcome back to Amruta's Blink. I am Amruta Kulkarni. Today we are going to discuss new chapter probability. This chapter probability comes under the section of mathematical ability or mathematical reasoning. In this video we will cover 10 practice problems covering basic concepts of probability. The video is again useful for school students 8th grade onwards. Besides, students who are preparing for competitive exams, graduation, undergraduate students, for all those students who have probability in their syllabus, even for bank POs, MBA and other entrance examinations. So let's quickly start the topic. In this video we will see 10 practice problems and their solutions on how to solve the questions based on the concept of probability. Let's start with first problem. A coin is tossed 2000 times with the following frequencies: head 1457 and tail 53 and tail 543. Compute the probability of getting head. This is very simple and direct question based on the concept of probability. Options are given: 0.455, 0.545, 0.7285, 0.543 and 1. Now it's given that the coin is tossed 2000 times. Now since the coin is tossed 2000 times, there are how many total number of events will be there? There will be 2000 trials or 2000 events. Hence n of s, that is sample space, is equal to 2000. Now we need to calculate the probability of getting head. It is given that when the coin is tossed 2000 times, 1457 times head had occurred, and hence probability of getting head is equal to number of heads divided by total number of trials, that is 1457 divided by 2000, which is equal to nothing but 0.7285, which is option number C. Let's move ahead with problem number 2. Two coins are tossed simultaneously 1000 times. We get two heads 500 times, one head 200 times and no head 300 times. Find the probability of occurrence of at least one head. Again options are given: 0.5, 0.2, 0.3, 0.7 and 1. Now in the previous problem there was a single coin which was tossed 2000 times, and hence sample space n of s was equal to 2000. But now in this problem two coins are tossed simultaneously 1000 times. So although there are two coins, but these two coins are tossed 1000 times, hence in this question sample space will be equal to 1000. So n of s is equal to 1000. Now when two coins are tossed simultaneously 1000 times and we classify the outcomes, then there were 500 events in which both the coins were having two heads. Now there were 200 events in which there was only one head, and there were 300 times in which there were no head. That means in 300 events there on both the coins it was tail. Let's suppose we will denote all three events, that is two heads, one head and no head, by E1, E2 and E3 respectively. Now how to calculate the probability of getting two heads, that is probability of E1 is equal to n of E1 upon n of s. So n of E1 is equal to 500 because there were two heads were occurred 500 times and n of s is nothing but 1000. Hence probability of E1 is equal to 500 upon 1000, that is 0.5. Now probability of E2. So probability of E2, what is event E2? E2 is an event where there was at least one head out of both the coins. So probability of E2 is equal to 200 upon 1000, that is 0.2, and probability of E3, that is probability of no head, that means on both the coins there were only tail. It is probability of E3 is equal to 300 upon 1000, that is 0.3. Now what we need to calculate is probability of occurrence of at least one head. So we can consider the event where there was one head on either of the coin, or we can also consider the event in which there were head on both the coins. Hence the required probability is equal to probability of getting two heads as well as probability of getting one head, that is probability of E1 plus probability of E2 is equal to 0.5 plus 0.2, that is 0.7. Hence our answer option is 0.7, that is option number D. Let's move to problem number 3. A bag contains a red ball, a blue ball and a yellow ball, all the balls being the same size. Kirti takes out a ball from the bag without looking at it. What is the probability that she takes out a red ball? Now again, this is a very basic problem from the chapter probability. Just very simple question that there are three balls each of different color, and we need to calculate the probability of choosing or picking one ball from the basket. Options are given 1 by 3, 1 by 2, 1 by 4, 0 and 1. So let's understand the question. Kirti takes out a ball from the bag without looking at it. So it is equally likely that she takes out any one of them. That means, what do you mean by equally likely is probability of choosing or picking red ball or blue ball or yellow ball is same. There is no specific weightage to any specific preference to any of the color. Now how many total balls are there? There are total 3 balls. So what is sample space? So in this problem n of s is nothing but 3, and as there are total 3 ball but red is 1, blue is also 1 and yellow is 1, and she wants to take out a red ball. So n of r will be nothing but 1, and hence probability of r, that is probability of picking red ball, is equal to n of r upon n of s, that is 1 upon 3, and hence answer option is A, 1 by 3. Let's move to problem number 4. Suppose we throw a die once. What is the probability of getting a number greater than 4? 1 by 3, 2 by 3, 0, 1 and none of these. Now as shown in the picture, when we throw a die, there are 6 possibilities. As in, on the upper face we can either get 1, 2, 3, 4, 5 or 6. So there are 6 possible outcomes. Hence n of s will be equal to 6. Now what we need to calculate is, we need to calculate the probability of getting a number greater than 4. So the required event, so the favorable outcomes can be 5 or 6. Hence how many number of favorable outcomes are there? That is 2. So either way 5 is also favorable outcome or 6 is also favorable outcome in this question, and hence probability of the event, that is probability of the number greater than 4 is equal to 2 upon 6, that is equal to 1 by 3, and hence it is answer option A. Let's move to problem number 5. Suppose we throw a die once. What is the probability of getting number less than or equal to 4? Now in previous problem we have calculated probability of the number greater than 4. Now in this problem we have to calculate the probability of getting a number which is less than or equal to 4. Again answer options are given 1 by 3, 2 by 3, 0, 1 or none of these. Now here let's suppose f is an event of getting a number less than or equal to 4. Now as discussed in the previous problem, how many total number of possible outcomes are there? 6, because a cube or a die has 6 faces. Now we need to calculate probability of getting a number less than or equal to 4. Hence favorable outcomes will be 1, 2, 3 or 4. Now here equal to 4 is also given. So less than or equal to 4, and hence we have to consider 4 also. So how many number of favorable outcomes are here? That is 4, and hence probability of this event F is equal to 4 upon 6, that is 2 upon 3, and hence it is answer option B, which is 2 by 3. Let's move to problem number. Suppose we throw a die once. What is the probability of getting a number 8 in a single throw of a die? 1 by 3, 2 by 3, 0, 1 and none of these. Now, when we throw a die, there are 6 possible outcomes can be there. That is, we can either get 1, we can get 2, we can get 3, we can get 4, 5 or 6. But on a die, getting a number 8 is not a possible event, that is, it is a impossible event. Hence, the favorable outcomes to get number 8 in a single throw is equal to 0, and hence the probability of getting a number 8 in a single throw of a die is also 0, because it is an impossible event. So you can also remember that for any event which is impossible event, the probability is always equal to 0, and on the contrary, an event which is very certain, in that case probability is 100%. That means for a certain event, probability is always equal to 1. Hence answer option is C, that is 0. Problem number 7. Two players Ram and Shyam plays a chess match. It is known that the probability of Ram winning the match is 0.62. What is the probability of Shyam winning the match? 0.62, 0.38, 0.48, 0.56 and none of these. Now, two players are there who are playing a chess match. So, Ram and Shyam are playing a chess match. Now, it is given that probability of Ram's winning the match is, let's say, P of R is equal to 0.62. Now, we need to calculate the probability of Shyam winning the match. So, probability of S is equal to 1 minus P of R, that is 1 minus 0.62, which is equal to 0.38. Now, why we have done this 1 minus 0.62 is for all the possible outcomes in probability. For all the possible outcomes, if we calculate probability, then the summation of the probabilities of all these outcomes is always equal to 1. Hence, in this case, as both of them are playing the match, so probability of R plus probability of Shyam, P of S is always equal to 1, and hence P of S is equal to 1 minus 0.62, that is nothing but 0.38, which is answer option B. Let's move to problem number 8. Vaibhavi and Heram are friends. What is the probability of both will have a different birthday, ignoring a leap year? 364 by 365, 1 by 365, 11 by 365, 363 by 365 and cannot be determined. Now, this problem seems to be simple, but at the same time we need to understand what is exactly asked in the question. Now, and one more thing is, ignoring a leap year, this information is also equally important. Let's say there are two friends, Vaibhavi and Heram. Now, out of two friends, let's say Vaibhavi's birthday is on any particular day of the year. Now, it is a well-known fact that the birthday can be on just any of the day, that is on any of one day of the year. So, out of 365, ignoring a leap year, that means in that particular year there will be how many days? There will be 365 days. So, out of 365, Vaibhavi's birthday can be on just one day, that is any of the day out of 365. Hence, we can consider the probability of Vaibhavi's birthday, that is P of V, is equal to 1 upon 365, as there are total 365 outcomes. Now, in the complete year, what we need to calculate is what is the probability that both of them are having different birthday. So, let's suppose Vaibhavi's birthday is on 1st of April. Then, in order to find out Hiram's birthday, we just have one information that both their birthdays are different. So, it is definitely sure that Hiram's birthday will not be there on 1st of April. And also it is not a leap year, so there are total 365 days. So in order to find out what is Hiram's birthday, there are 365 minus 1, that is 364 total number of possibilities are there. Hence, Hiram's birthday can be there on remaining 364 days. Hence, probability of Hiram's birthday is different from Vaibhavi's birthday is equal to this 364 divided by 365, that is answer option A. This problem was slightly a difficult problem, as in there was absolutely no calculation, but conceptually we need to understand what is the concept of leap year and how to find out the exact required favorable outcomes of the required event. Let's move to problem number 9. Two dice, one blue and one grey, are thrown at the same time. What is the probability that sum of two numbers appearing on the top of the dice is 8? 5 by 36, 0, 1, 1 by 36 and none of these. Now, two dice are thrown simultaneously, one blue and one grey. Now, both of them can have 6 possible outcomes. So, blue die can also have 6 possible outcomes. At the same time, grey can also have 6 possible outcomes, and they are thrown simultaneously. So, total number of possible outcomes will be 6 into 6, because there will be different combinations at each time. Hence, number of possible outcomes is equal to 6 into 6, that is 36. So, n of s, that is sample space, will also contain 36 events. Now, what we need to calculate is the probability that sum of two numbers appearing on the top of the dice is 8. So, the possible summation on each dice is 8. So, let's suppose now on the first die, if we get 1, then 1 plus and maximum number which we can get on the second one is 6. So, but 1 plus 6 will be equal to 7. Hence, we cannot pair 1, we cannot have 1 in any of our favorable outcomes. So, what all can be the favorable combinations of the outcomes is 2 and 6. So, suppose on first die we get 2 and second one we get 6. Similarly, on the first die we get 3 and second one if we get 5 number, then it will be a favorable outcome. On first die 4, second die also we can get 4. On first die 5, we can get 3 on second one, and on first die we can get maximum 6, and on second die we can get 2. So, how many possible outcomes are there? How many favorable outcomes are there? We can have 5 favorable outcomes, and hence probability of this event is equal to this 5 upon 36, that is answer option A. Let's move to last problem of the video, problem number 10. Cards numbered 1 to 20 are mixed up and then a card is drawn at random. What is the probability that the card drawn has a number which is multiple of 3 or 5? 1 by 20, 9 by 20, 1 by 5, 1 by 6 and none of these. Now, cards numbered from 1 to 20 are mixed up. So, n of s will be equal to 20. Now, what is the event that what we need to calculate is the card which is drawn at random should have a multiple number of 3 or 5. So, we can either have 3, we can also have 6. Now, 3 or 5. this OR is very important. So we can have either multiple of 3 or we can also have the multiples of 5. Hence favorable cards will be, we can either have 3, 6, 9, 12, 15 or even 18. 21 we cannot have because how many maximum cards are there? 1 to 20. We can also have multiples of 5, that is 5, 10 and 20. So how many possible outcomes are there? N of E is equal to 9. N of S is 20 as we have already discussed, and hence probability of this event is N of E upon N of S, that is 9 upon 20, which is answer option B. So in this video we have discussed 10 problems covering basics of probability. In next video we will come up with new chapters and more practice problems. Thank you.